Well, good morning everybody. Today we're doing simple machines and I'm going to show you in this video how we can use just a simple ruler like this as a lever, and I'll show you how it works. Now you should be able to see, this is my kitchen table, my dining room table. I've got my ruler. Now a lever is any rigid bar that pivots on what we call a fulcrum or a pivot. So I'm just using a pen as my pivot. This is my ruler, which is the lever, and this is just a toy block. Doesn't weigh much, but it serves the purpose. Okay, so you can see I'm putting the ruler fairly unevenly on the pivot, and the block is on the short end. And look, for weights, I've got a whole heap of 20-cent pieces. This is just a bit over $2 worth. So when you're at home, you don't have to be really rich, but if you can get a few of these, any coins will do. I've also got some dollar coins there. But we'll just see what happens when the lever is, the long end's here, and the load is on the short end. Let's see how many 20-cent pieces can actually lift that block up. So here goes one. Oh, look at that. And one 20-cent piece does the trick. All right, now let's just move the lever so that the pivot or the fulcrum is roughly in the middle. And let's see what difference that makes. So there's 1, 2, 3, 4, oh, getting there, 5. Okay, so 5. It now takes 5 20-cent pieces to lift the block. So you can see we've lost what we call mechanical advantage. So remember here, when the ruler was up here, oh, let me get that right. So around the 3-inch mark, for us oldies, it took just 1. Bingo. And we move it halfway, and it actually takes 5. Now, so 5 times the amount of effort or strength to lift it. Now, what if we move the fulcrum right up here? So now the load is on the long bit of the lever, and we're going to put the effort onto the short bit. So I'm going to put the 5 coins that we had before, and that's not doing anything. I'm going to add 5 more, so we double the amount of force. It still isn't doing anything. So here's 3 more, and it still isn't doing anything. Now I've run out of 20-cent pieces, so I'm going to add dollar coins one by one. 1, 2, 3, wow. So you can see it takes quite a lot more force on the lever when you're putting the effort onto the short end of the lever. Okay, finally, there we go. We've done it. I haven't counted these, but that's not the point. The point is it takes more strength when you have the short end of the lever on the effort and the long end on the load. Look, that's the science behind a lever. At home, some of the more simple things. Look, here's just a can of chocolate. Now, it's got a lid like a can of Milo or something. If you try and open that up with your fingers, I mean, you can do it, but it's very, very hard. You've got to actually put a lot of strength, particularly if it's put on properly. You've got to put a lot of strength in your fingers to do it. Something as simple and everyday as the spoon. Using as a lever, the actual rim becomes the pivot point or the fulcrum. And you can see you put your spoon in there. The spoon pivots on this part of the tin, which is the pivot or the fulcrum, and it's easy. Bang. You can open that up. So in your homes, you use machines almost every day if you drink Milo. Just a simple spoon. One for the adults. Here you go. A bottle of nice refreshing ale and a bottle opener. And you can just... If you tried to open that with your fingers, it would be really, really hard. Just ask your dad or your mum. I'll just shift that up a little bit. But if you use one of these, it's easy peasy. Just flick it on there. And I won't open it now because it's early in the morning. It's way too early to drink this sort of stuff. But you can just easily pop that open. All right, that's the science of the lever. I hope you can experiment at home and realize that we use simple machines every day, doing our everyday things, and the lever is just one example.